Hi there. How's it going? Welcome to another session of Brain Training, a place where I train my English by explaining LeetCode solutions. LeetCode solutions, that's what I do. For today's session, we're going to tackle the group anagrams. Let's go right away. Let's go right into this question. Without further ado, let's go right. Man, I always mess this up. Always mess this up. I don't. I'm not going to change. Let's keep on going. So first thing we have to keep in mind, this is a medium question. Not that this change anything, because for me, my opinion, all questions from lead code, they're hard questions. We have hard questions, very hard questions, and extremely hard questions. That's what we got. But each question has these labels like easy, medium, and hard. But this is a hard one. What usually means is that this requires previous knowledge or more knowledge about some techniques, some obscure techniques, advanced algorithms, and whatnot. But for this question, the requirement is solving in the optimal way this valid anagram question over here. You should have already solved this question over here. First, go ahead, solve this question in an optimal way, learn the technique, and then you can come back to this one, and you'll be good to tackle this one without too much concerns. With that in mind, let's go to this question, understand what is its requirements. Now, this question just is asking us to group the anagrams together like this, group them, find the anagrams, and group them together. It's anagrams, actually, the pronunciation, but doesn't matter. After we find a way to group them together, we have to return all groups in a single list. And how are we going to do this? So we know that an anagram is two or more words that contain the same letters. With that in mind, we know if we sorted those words, they will look exactly the same. The sort version of those two words or more words will look exactly the same. That's a property of anagrams. The sorted version of this word is this, and the sorted version of this word is also the same thing. We're going to leverage this property so we can create a key, use this information over here, the sorted version of the, the original word as a key to group all the anagrams, this sorted version. This is how we're going to solve this problem. It goes without saying that this is a hash map because we are saving things with keys. After all iterations over this input array, we're going to end up with this group hash map. And then we just have to wrap all those values into a single list. And there we have it. This is the easiest and the simple way to solve this problem. As a matter of fact, to come up with this solution over here, you don't need to go over this valid anagrams, like the optimal solution. This is the naive approach. For now, it's good enough. So let's go over the code for the solution. The code looks something like this. We cannot directly convert a string, so we're going to convert first to a char array, sort it, and then convert back to a string. That's ugly, but Kotlin, right? Now the next step is going to the group and get or put to the key. So what this method does is basically I need the location for the values of this key. If you don't have anything in this location, I will add a default value. So it's going to be a mutable list of, here we are just leveraging the inference property, a Kotlin inference. That's just, we don't need to explicitly tell the type parameter like this. The compiler will understand that this hash map expect to receive a mutable list of strings. So we can use inference to make this concise. By the way, this is one of the things that I love about Kotlin, inference. Let's keep on going. With this, we guarantee that at least we going to have a empty list there, and then we're going to add the string. We find it. I don't think we need anything else here. After that, we are good to go out of this loop. Yeah, here we just generate the keys, and here we just adding the new word. After that, we just have to, like I said, wrap all values of this hash map into a list. That's what we got. This is the entire code we need. And let's give this a try. And that's what we got. This is memory. This is runtime. Looks nice. It's a good performance here. I think this is a nice approach. It's not the optimal way, but for me, it at least looked good. So let's go over the time complexity for this algorithm. Inside the loop, we'll have the heaviest operation, that is sorting. For each key, we have this time complexity. And for each string, we have time complexity O of n. And the overall time complexity will be O n times key log key. This is what we got for time complexity. It's a fancy one, right? But it's not that bad. It's not that bad. Just a side note here. This is not the same approach because of this toString. This toString is not converting the sorted char array to this, to look like this. My solution here, the keys will look like this because of this toString. To make the keys look like exactly the way I described in the walkthrough, I have to use this join toString. This will take the array, the char array characters, and join to a string without any delimiter. So we're gonna put all together in a single string, and with that they will ended up looking like this. This is just a bonus tip, just a side note here. This was my mistake. Let's run this again, and most probably that will work. What the is a typo here? It's join. It's not joining. And the performance is a little bit worse. So yeah, without even knowing, I make my code a little better just by not joining to a string, rather doing just to a string, and use the keys as the string version of the char array. Let's see again. So we have this performance, and let's submit again to see the improvement. Yeah, a little bit of improvement right there. Good to know. Another bonus for the solution is we can write this using single liners in Kotlin, because we can leverage the standard functions of collections in Kotlin. So let's rewrite this in the single line format. We're going to use the group by function. This is the most important. This will iterate over this entire array, do exactly what we're doing here. But instead of manually doing this, you're going to use this function over here that does exactly this. Iterate over the entire array and group the elements by a specific key. This is going to be the key. And we'll group them together into this key. This is exactly same thing is happening here. And this function will return a hash map. After that, we just have to get the values of this hash map into list. Same thing we did here. I'm having a great time here. So we can achieve the same thing using a single liner. That's nice, right? That's really nice. I like it. But anyway, just want to show that we can write this in a different way. I find this interesting. At least I find this really cool and interesting, so I want to share it. But now let's try to improve this a little bit. Let's see if we can improve a little further this algorithm by using the frequency counter. Let me explain real quick. So let's just a recap of this technique. Not gonna go into too much details. I already did a video about it, explaining what this technique is all about, but it's basically this. So instead of using the sorted version of the string as keys, now we're going to use this frequency counter. It's basically a int array with 26 positions. Each position, as you can see here, represent a letter, and we're going to scan the entire word to count how many letters each word has. The words that are anagrams will end up with the same frequency counter, exactly the same, because they have exactly the same number of letters and the same positions. The 3 words has the same frequency counter, 1A, 1E, and 1T. This is how our frequency counter looks like under the hood. Now, instead of creating a key based on the sorted word, we're going to create a key based on this frequency counter. So this is the change we're going to do, because to generate this, the cost of generating this frequency counter is less than sorting the word. This is going to be the cost, O of k, where k is the length of the word. So to generate this frequency counter, that is just a list of integers, this is going to be the cost. Well, this is the advanced approach we use to improve this solution over here. So this is why we need to understand this technique first in order to improve this implementation. So let's go over the code for this implementation. Here we have the function that generates the counter. As I said, we declared a mutable list with 26 position, all fill in with zeros, and then we iterate over the word. For each character, we just count the characters within this word over here, and then we just return the mutable list as a list of integers. This is how we generate the counter. And we're going to use this function inside the loop. Instead of sorting the word, we're just generating a counter for that word and use it as a key. Same thing that we did previously, just changing the key. So now we have a time complexity of O n times key. Perhaps this will improve our time complexity. So now we just have to return the same thing we did before, groups, values to list. Should work exactly the same. By the way, here we are using the nested function, a function inside another function. In Kotlin, functions are first-class citizens. First-class citizens. So we can use functions whatever we want, like inside another functions, outside classes, whatever place we want to use. We don't need to put wrap functions inside classes like this. But this is not important right now. Just saying. It's another thing that I find cool to point out. Okay, so let's see how this performance goes. The performance goes for this version. A lot of improvement right there. It's beautiful, beautiful improvement just by changing the way we generate the keys. Let's wrap this up real quick. My camera is off, but as far for space complexity, we have the same space complexity because we have a extra space for the keys. Those keys over here, we have to store those keys, the counters, and also the sorted version of the words. And extra space for the values we are storing on the hash map. This is why we end up with the same big O notation for space complexity. That's it. This is how we group anagrams together. We can group by sorting, and we can group by counting, by frequency counters. Either way, looks good, looks nice. I like this question a lot. I hope you enjoy as well. And see you in the next video. Bye-bye.